Hey everyone, and welcome to The Explainer. I am absolutely thrilled you're tuning in today because we're going to unravel one of the most mind-blowing everyday miracles of modern life. I mean, we literally use it constantly, right? But how many of us actually stop to think about the real physical reality of how our data travels? We tap our screens and boom, instantly, a whole world of information is right there. But there is a hidden, insanely high-speed physical journey happening right beneath our feet and across the oceans. So today we are going to completely demystify this invisible highway.
So really ask yourself for a second, how does a video actually get to your phone? We all kind of have this tendency to rely on this vague mental model of a, magical internet cloud. We imagine data just sort of floating through the air, or maybe we think an entire movie is somehow squeezed into a physical wire and shot across the world like water rushing through a pipe. It sounds a bit ridiculous when you say it out loud, doesn't it? Because the internet doesn't send the meaning of your message as floating text, and it for sure isn't beaming fully intact video files through the sky. It's time we completely break that illusion.
Okay, let's dive right into this. If we strip away all the tech jargon and complexity, the entire internet basically relies on one simple, beautiful rule. And here it is. The internet moves information by turning meaning into patterns, patterns into light, and light back into meaning. It's not sending pictures, words, or videos exactly as they are. It is sending coded signals, and light is the ultimate carrier. We're going to keep coming back to this beautifully simple rule of three throughout our time together today.
Why light rules the internet.
To really understand this rule of three, we got to look at our vehicle first. I mean, we have electricity, we have radio waves, but for the heavy lifting of the global network, light is the undisputed champion. There are three massive physical advantages here. First off, it moves extremely fast through glass fiber. We aren't waiting for a physical delivery truck, we are flipping states at the speed of light, which is just wild when you think about the sheer scale of it. Second, it can carry multiple signals at once without mixing them all up, which electrical signals tend to do. And third, it loses very little quality over huge distances. That means your message can travel way further with far less distortion.
Turning meaning into patterns.
So light is our perfect vehicle. But how do we strip information down for travel? At the smallest possible level, all digital information is built from bits. A bit is really just a tiny decision between two states. Think of it like a single bead on a piece of string. By itself, one bead tells you almost nothing, right? It's just a little piece of glass. But if you carefully arrange a specific color sequence across millions of beads, you can encode a breathtakingly complex design. The meaning doesn't come from the individual bead, it comes from the sequence itself. And what's really fascinating here is how the network actually reads these patterns. The internet usually doesn't care whether a signal is bright in some fuzzy, absolute human sense. It cares about clear differences. Think about a standard light switch on your wall. You don't need to get out a protractor and know the exact mathematical angle of the switch to know if the light is on or off. You just need to know if it's up or down. That totally clean distinction, light versus no light, high versus low, is what makes the message incredibly hard to confuse. Translating patterns into light. Now we have our meaning translated into a sequence of bits, those clear, easily readable patterns. Now we have to translate those patterns into light, the actual physical flashes that move across the world. The absolutely crucial point to grab here is that this is a continuous process of translation. We aren't transforming the actual meaning. Imagine giving a secret code to a friend where the letter A becomes the number 1 and B becomes 2. The secret code isn't the meaning of the message, it's just the container. The form changes from a thought to bits to light, but the underlying structure, the true meaning, survives perfectly.
Guiding light through glass.
Of course, you can't just shine a flashlight into the night sky and expect a computer halfway across the globe to somehow read the pattern. That's exactly where fiber optic cables come into play. And look, they aren't magic. They are simply highly engineered glass pathways. The glass acts as a controlled tunnel. Because of the specific angle and the material, the light just keeps bouncing safely inside the core instead of escaping out into the dirt or the ocean water. It basically creates a completely stable highway where these incredibly rapid changes in light can survive the trip.
Surviving the long journey. But here is the major conflict of our story. Long-distance communication is inherently messy. Stuff goes wrong. Cables get bent. Signals lose strength. Random interference happens. So how does this fragile little pattern of light survive crossing the entire globe without getting hopelessly scrambled? Well, a huge misconception is that your message travels in one continuous, unbroken shot. That is not what happens at all. The internet is actually a highly coordinated relay race. The runners, the routers, switches, and optical equipment, they don't carry the message the whole way. They carry it for a stretch, hand it off, and the next piece of equipment takes over.
And because the journey is broken up into a relay race, the message itself has to be broken up too. It doesn't move as one giant single file. It moves as packets. Packets are literally a brilliant solution to the messiness of the real world. By breaking a large file into small, independent chunks, the whole system becomes incredibly flexible. If one path gets blocked up, a packet can instantly reroute and take another path, avoiding the traffic jam entirely.
A super helpful way to think about a packet is to imagine a stamped envelope. Inside, you have a piece of the actual message. On the outside, you have the destination address telling the network where it belongs, and importantly, you have confirmation data. The postal system, or in our case, the internet equipment, doesn't need to understand the photo or the text inside the envelope. It just needs to read the outside, protect the pattern, and send it to the right place.
Rebuilding the original meaning.
Eventually, all these individual envelopes, these flashes of light traveling as packets, arrive at their final destination. And this brings us to the final crucial step. Remember how we talked about those clear differences? Up or down, light or no light? When the signal reaches its destination, translation stations detect those clear states. This is the big, triumphant moment. Because the system relies on structured chunks and clear boundaries rather than fuzzy guesses, it can perfectly rebuild the bits. The messy journey is over, the data is safe, and as long as the receiver can tell an on from an off, it perfectly reconstructs the pattern.
Think about how this applies to everyday life. It's exactly like a recipe. You can write a recipe on a piece of notebook paper, you can type it into a phone, or you can speak it out loud to a friend. The physical surface changes, sure, but the recipe, the pattern of instructions, stays the exact same. Data is a structure, not a physical object flying through a wire. When the destination reads that light pattern, it's just reading the recipe to bake the exact same digital cake you sent.
So we circle back to our core mantra. And when you hear it now, notice how much more depth it carries. The internet moves information by turning meaning into patterns. Those are our bits. Patterns into light. That's our encoding and our packets traveling through glass fiber. And light back into meaning. That is the receiver detecting the clear states and perfectly rebuilding the message. You really no longer have to view the internet as some mysterious, magical black box. It's a chain of readable, beautifully engineered patterns.
I am going to leave you with this one thought. The next time you tap to load a web page, or stream a movie, or send a quick message, just pause for a second. Can you see the invisible relay race of light happening right there behind your screen? Because millions of tiny structured flashes of light are racing through glass tunnels all across the globe, literally just to bring that exact meaning right to your fingertips. Thank you so much for joining me on this explainer, and keep looking for those fascinating systems hidden right beneath the surface of our everyday world. Catch you next time.